Welcome back. Now here we are going to discuss the last token, that is data type. So here we start with the data first. What is a data? Data is simply a value. Dictionary meaning of data is it is a raw fact, a value. Now this value can be of any type, right? So this value can be of any type. So here particularly we are going to discuss that what are the type of values we can work in Python. That is all about data type. So data type tells us basically three things, right? The first one is what are the type of values we can work in Python. What will be the type of values that will be supported by Python. Second, what will be the space required in memory to store that value, right? What will be the space required in memory to store that value? And the third is what is the range of value we can store in that space, right? So basically data types tells us three things. The first, what type of data we can work in Python, what will be the space required in memory to store that data, and what will be the range of value it can store in that available space. So this is what data type tells us. So here data types comes in two flavors in Python, that is simple data type, primitive data type, or it can also be termed as primary data type, and the other one is complex data type or secondary data type. Now the difference between primary and secondary data type is something like you can understand it by the example that suppose we are making a tea. So this tea is made by use of other two liquids, that is water and milk. Now water and milk are the natural resources liquid, right? These are the liquids we get from natural resource. And the tea that we make, this is also a liquid, but we make use of the liquids that are naturally occurring and then we make a tea. So the tea is made by human. So the water and milk will be termed as primary liquid and the tea will be termed as secondary liquid. The same is the thing with data type over here. Simple data type is the data type, are the data types that comes with the bundle of Python, and secondary data type are those data type that are made by the programmer using the primary data type, of course following the syntax and rules and regulations of Python, right? So here we go simple data type and complex data type. As I said, simple is also termed as primary or primitive data type and complex is also termed as secondary data type. So in simple data type we have three categorizations: numeric, none and string. And in numeric we have integer, boolean, float and complex. Here float and complex can be bundled under real values, bundled under real data type. And in complex data type we have list, tuples and dictionary. So in this module, in this video, we will be discussing about simple data type, and complex data type we will be discussing further, because list, tuples, dictionary, all these are individual topics, right? So here we are going to start with simple data type, that is numeric, none and string. So the first one is integer. Now what is an integer? Integer is simply a value where it can be a negative number, it can be a positive number, but without the fractional part, without the decimal part, right? So integers are the value without the fractional part. It can be negative, it can be positive, and it is represented by int. The short representation of integer is int, and the default storage space required by integer is 28 bytes in Python, and this 28 byte is also dependent on the operating system you are using and the architecture of your system. Now this 28 byte I have written here because I am here working on 64-bit operating system Windows 10, right? So this is what integer is. So integers are the numbers without fractional part, without decimal numbers. It can be negative also, it can be positive also, represented by int. Short form is int, and its default size is 28 bytes. So in computer system, in Python, integers can be of various types. Okay, we have different representation techniques for integers. It can be a decimal number system, it can be an octal, it can be hexadecimal, and it can be binary also. So we are going to discuss each of one of them with an example. So the first one is that we follow in our general life, that is decimal number system. Okay, so decimal number system, the symbols that are used are from 0 to 9, that is 10 symbols are being used. So the base of decimal number system is 10, right? So what is base? Of course you must be knowing, in mathematics you might have learned. Suppose the value is 286, right? So how these values are evaluated, the place value, how it is evaluated, 6 will be multiplied by 10 raised to the power 0 plus left hand side value of 6, that is 10's place, will be multiplied by 10 raised to the power 1, and 2 will be multiplied by 10 square. So what we get is 200 plus 80 plus 6, and this goes to 286. So this is how we calculate. So that's why its base is 10, because the base value, place value of individual digits of a number is calculated by multiplying that number with 10 raised to the power 0 for the unit place, and then it keeps on increasing by 1. This is what a decimal number system is. When we talk about binary number system, okay, so binary number system only has two symbols, that is 0 and 1. So its base is 2. So I will give you an example. Let's take an example of 15 of a decimal number system. If we have to calculate the binary equivalent of 15, what we will be doing is 15 divided by 2, and we will keep it on dividing till here the value becomes 0. So 2 7s are 14, remainder is 1, we will keep it here. 2 3s are 6, remainder is again 1. 2 1s are 2, remainder is again 1. And now because only one is left, last digit is 1, so we will stop here and we will write from bottom to top in reverse order. So because all are 1, so it will be same from top to bottom or bottom to top, and this is the binary equivalent of decimal number 50, right? So this is how we calculate binary numbers. Then comes your octal numbers. Okay, so octal numbers are having the symbols from 0 to 7, and because 8 digits are there, so its base value is 8, its radix is 8. Now suppose if we have to calculate the octal equivalent of 15, then we will be doing the same process, but this time not with 2, this time with 8, because its base value is 8. So 8 ones are 8, and what will be the remainder here? Here it will be 7. Now only 1 is left, so we will stop here, and now we will write it in reverse order from bottom to top. So the value will be 1 7. So this will be the octal equivalent of 15. Okay, but in Python, how we are going to represent this octal equivalent of 15? It will be written as 0, then O followed by the result, that is 17. This is the representation of octal number in Python. And then the next comes is hexadecimal, right? Hexadecimal, it uses 16 symbols from 0 to 9, and then from 10 onwards up to 15 it uses A, B, C, D, E and F. So 10 is represented by A, 11 is by B and 15 is by F. So here 15 equivalent of decimal number in hexadecimal, it will be simply F, right? Because 15 is represented by F. And the way to write in Python is 0, X, it can be small or capital both, and then a number itself. This is the representation of hexadecimal in Python, right? So I hope you may have got the concept behind the number system in Python. So this was about integer. Now the next data type is booleans. Booleans represent one of the two values, that is true and false. That is, it is in the form of logical values. Okay, it is of the form of logical values. So if we talk about numbers, the false is equivalent to 0 and true is equivalent to 1. We can verify it by using the bool function. Bool 0 will return false as an answer and bool 1 will return true as an answer. Its default size in memory is 28 bytes. Now if you remember what we have learned earlier, relational operator and logical operator. So those relational operator and logical operators were used to compare the values and were returning the results in logical form. Now the values that were returned by the relational operator and the logical operators, those values were Boolean values because they were returning true and false as a result. So this was all about Booleans. Now the next comes is real numbers. So real numbers, we have two parts, float and complex, right? So the very first one is float. In float, we represent the number in decimal form, that is in fractional form. And float representation can be done in two ways: the traditional method that we follow, that is fractional form, and in the exponent form. Fractional form is simply a traditional number. Here we represent a number in decimal part, that is 55.67 for example. This is a fractional form. Now if the same number 55.67 has to be converted in exponent form, then what we will do is we will simply normalize this number and move the decimal number just after the first value. Okay, so what we will be doing is we will be writing it is something like this, 5.567, but the actual number was 55.67. So to get the actual number, what we can do is we can multiply it by 10 raised to the power 1, right? Now this portion can be written as 5.567E01. Now this 01 represents the power of 10, right? So this is what exponent form, conversion from fractional form. So this portion is known as mantissa and this portion is known as exponent. Now this is how float values are represented in Python. The default size of float value is 24 bytes. Now the next data type is complex. Complex simply represents a number of the form a plus bi, where I is an imaginary number. It is an imaginary number because its value is equivalent to root of -1. And we know that root of -1 does not exist. That's why it is known as an imaginary number. In Python, instead of I, we make use of j. So we can say that here the number is of the form a plus bj, where j is an imaginary number, right? Let us discuss it with an example. Suppose a number is z equals to 1 plus 2.5j, right? So here this number has two parts. The first part is real part and the second part is imaginary part. Means here the value 1 is a real part and the value 2.5 here is an imaginary part. Now what we can do is we can bifurcate these two values, making use of dot operator and the keyword real and image. Suppose if we write z dot real, what we get as a result is 1 in this case, and if we write z dot image, what the result we get is here 2.5, right? So this is how we can bifurcate the real and the imaginary part of a complex number. The default size is 32 bytes of a complex number, right? Now the next one is none. None is simply a value that represents null, means nothing. Nothing value is present. No value is present, right? Not even zero, not even false, not even an empty string. Nothing. You can simply correlate it with the term vacuum. In vacuum, nothing is present. Not even air is present. So similarly, here the none is. None means nothing. Absence of any value, right? So this comes the end of this video. In the next video, we will be discussing about next data type, that is a string. Till then, take care. Goodbye.